Every day, millions of people step into elevators without giving it much thought. A metal cabin, suspended in a vertical shaft, moves smoothly through empty space, carrying people dozens or even hundreds of meters above the ground. There are no seat belts, no visible safety systems, and no sense of how the machine actually works. Yet elevators are among the safest machines ever built. The idea that an elevator might suddenly fall is deeply rooted in popular culture, but it is also one of the biggest misconceptions about how elevators function. The fear of falling is one of the most ancient fears in the human mind. Long before modern technology, a single misstep could mean serious injury or death. Elevators trigger this instinctive fear perfectly. We enter a confined space, the doors close, and the floor begins to move. Outside the walls is nothing but air. We cannot see the cables, the motors, or the brakes. When the brain lacks information, it fills the silence with imagined danger. Engineers understood this fear from the very beginning, and modern elevators were designed not just to move people, but to eliminate the possibility of catastrophic failure. One of the most common beliefs is that elevators are held by a single cable, and that if this cable were to snap, the cabin would fall straight down. In reality, modern elevators are supported by multiple steel cables working together. Each cable is strong enough to carry the full weight of the elevator on its own. Even if several cables were somehow damaged at the same time, the remaining cables would still be able to hold the cabin in place. This alone already makes the idea of a sudden free fall extremely unlikely. Elevator cables are not simple ropes. They are made from braided steel strands, carefully engineered to bend over pulleys thousands of times every year without weakening. These cables are tested to withstand loads far greater than anything they will experience in daily operation. In most elevators, the total strength of the cables exceeds the maximum working load by many times. Elevators do not operate near their limits. They operate with enormous safety margins. For a cable to fail, it would require extreme neglect, severe corrosion, or deliberate sabotage over a long period of time. Another critical part of the system is the counterweight. An elevator is not lifted directly by a motor pulling the cabin upward. Instead, the cabin is balanced against a counterweight on the opposite side of the shaft. This counterweight weighs almost the same as the elevator cabin with an average number of passengers inside. Because of this balance, the motor only needs to move the difference in weight, not the full load. This makes the system more efficient, more stable, and far easier to control. It also means that even if something goes wrong, gravity does not automatically pull the cabin downward. Many people assume that a power outage would cause an elevator to fall. In reality, power loss is one of the safest conditions for an elevator. Modern elevators are equipped with electromagnetic brakes that are designed to activate automatically when power is lost. When electricity stops flowing, the brakes engage and hold the elevator in place. The cabin slows down and comes to a controlled stop. In many cases, backup systems then move the elevator to the nearest floor and open the doors. This behavior is intentional. Elevators are designed so that the absence of power makes them safer, not more dangerous. The most important safety feature in an elevator is not the cables, but the braking system. Modern elevators use mechanical speed governors that constantly monitor how fast the cabin is moving. If the elevator begins to travel faster than it should, even by a small margin, the governor activates. Steel clamps lock onto the guide rails on both sides of the shaft, gripping them with enormous force. The elevator cabin is brought to an immediate stop. This system is entirely mechanical. It does not rely on software, sensors, or electricity. It is based on simple physical principles, which makes it extremely reliable. Technically, it is possible for an elevator to descend rapidly under very rare circumstances. However, This is not the dramatic free fall shown in movies. Even in these rare cases, multiple safety systems engage almost instantly. The result is a short, controlled drop followed by a hard stop, not a continuous fall. Statistically, elevators are far safer than cars, airplanes, or even staircases. Most elevator-related injuries do not come from falling. They occur when people trip while entering or exiting the cabin. Movies often portray elevators as fragile machines hanging by a single cable, ready to plunge at any moment. This image exists because real elevator behavior is not dramatic enough for entertainment. A real elevator failure would be brief and uneventful. It would stop quickly, often without passengers fully realizing what happened. In the real world, elevators are inspected regularly, maintained carefully, and tested under strict safety regulations. No single component is ever trusted on its own. Elevators are built around the philosophy of redundancy. Every critical system has backups, and those backups often have backups of their own. This approach assumes that something will eventually fail, and plans for that failure in advance. The same philosophy is used in aviation, space exploration, and nuclear power systems. Elevators adopted this mindset early because they operate in an environment where failure is unacceptable. The reason elevators almost never fall is not luck, and it is not coincidence. It is the result of layered engineering. Layers of steel, layers of brakes, layers of mechanical systems, and layers of safety rules working together. When you step into an elevator, you are not trusting a single cable or a single machine. You are trusting decades of engineering experience, countless tests, and systems designed under the assumption that something will go wrong. And when engineers design machines with failure in mind, that is when technology becomes truly safe.